Okay, welcome to the pre-skills lesson for Unit 4, Complex Numbers and Rational Exponents. So where we're going to start is exponents, exponent laws, and radicals. Okay, a power. A power is a combination of a base and an exponent. The whole thing is called a power, or it is called exponents. But exponent just refers to the number at the top right. Exponents deal with multiplication only. The number at the top, the exponent, tells you how many times to multiply a number to itself. All right, you can read through this slide, but anything to the second power is called squared. Anything to the third power is called cube because squares deal with area, cubes deal with volume, and these actually get measured. Okay, so what exactly is an exponent? So you look at the exponent and you multiply that number to itself. So 3 squared means 3 times 3, which is 9. 3 cubed means 3 times 3 times 3, which means 9 times 3, which is 27. And 3 to the fourth power means 3 times 3 times 3 times 3, which is 27 times 3, or 9 times 9, which is 81. Okay, what is a square and what is a square root? When you multiply a number to itself, that's called a square. Squares and square roots are special types of multiplication. Square is a number multiplied to itself. That's all it is. Because why? It makes a square. When you learn your multiplication table, a square is the leg, and then you multiply it by the other leg, and you get what's called area. All the area inside of a square or some object. A square root is the opposite. It is a special type of division where it's the same number multiplied to itself. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. The square root of 25 is 5. Now, most of the times you'll only see the principal square roots, but all square roots, when you take the square root of a positive number, you get a positive number and a negative number. Only when you take the square root of a positive number. Most times the negative will be left out, but we have to remember this for our calculations. So squares and square roots are equal and opposite, just like multiplication and division. And if you look at a multiplication table, we can see that a square, if I say 6 squared, it makes a square, and we are consuming all of the area inside the box. In our bottom right corner happens to be 36. 6 times 6, or 6 squared. 6 times 6, or 6 squared, equals 36. And if you go diagonally down the multiplication table, you will see all of the perfect squares. A perfect square is an integer multiplied to itself. Multiplied so perfect whole numbers. And we know integers are whole numbers with signs in front of them. Okay, when you take the square root of something squared, you get that thing out, because we're going to learn this when we get to radicals, but the square root, a 2 should sit here. And basically what happens is that the numerator is under the radical, and we'll talk about this later. So that 2 goes there, and the 2 here is related to the index, and we're going to talk about this later. So we know that 2 divided by 2 is 1, so that's x to the first power. And mathematicians are lazy. They don't like to write ones, but any number or letter by itself has a power of 1. There's one of them. Okay, so a square is basically the leg, a square root is basically the leg of a square. So if this whole area contains 64 units, this whole area was 64 units, and you can see count 64 squares. If you take the square root of this square, you will get 8, which is the length of a leg. Okay, now cubes and cube roots follow the same rules and laws that squares and square roots do. So, cube, again, if I take a number like x or a letter like x, the 3 goes under the radical in the numerator, and the 3 in the denominator goes with what's called the index. And we know that 3 divided by 3 is 1, and that equals x to the first power, which is the same as writing x. Mathematicians are lazy. They don't like writing ones. Okay, now the cube root of 64 equals 4. So basically what you have is 4 cubed, and you take the cube root, and that's how you get 4 out. So cube roots undo cubes. Cubes undo cube roots. Just like squares and square roots undo each other. It's the same thing, except for you have 3 of a number multiplying to itself. And basically what cubes do is they make 3-dimensional figures. So 3-dimensional figures are called volume. What a cube represents is volume. Just like a square represents area, cubes represent volume. Okay, now let's talk about radicals. The degree is a little number on top of a root. Now, most of the times you will not see a 2. Whenever you see a radical sign, the funny looking division symbol, you will not see the 2. That you're supposed to assume that means square root. But sometimes we have different degrees. Sometimes we can take the cube root, the 4th root, the 5th root, the nth root, any root. And then you have the radicand. That's the term or the number under the radical sign. And so the way radicals work out is that the exponent is the numerator. So we're going to write exponent equals numerator in a fraction. And the index equals the denominator. If we were to change a radical into a rational exponent. And when we hear the word rational, we have to think the word fraction. Whenever you see rational, think fraction, even if it's a decimal. A rational number is a decimal that can be turned into a fraction. Okay, now, how to simplify radicals. How we simplify radicals is you need your perfect squares. It must be the product of a perfect square and another number. Because when you take the square root of a perfect square, you get an integer out. It comes outside. So 72, you need the perfect square of 36 and another number. For 320, you need to find the largest perfect square that will go into it. And how do we know? We keep dividing. We'll just keep dividing by perfect squares. And there is a perfect square chart that you will need. Look at your multiplication table or look at a squares chart to see. And we would divide 320. We would do it by 1, by 4, by 9, by 16, by 20. We would keep going until we got the largest number that was whole. That could go into 320. Okay, now the last thing we want to talk about is exponent laws or exponent rules. Here are some of the rules. The zero exponent, we're going to use all of these rules. The product rule. Anytime you multiply the same base, add the exponents. Quotient rule. Anytime you divide the same base, subtract the exponents. The power rule. When you raise a power to a power, multiply the exponents. Power of a product. If you got different bases multiplied, the exponent will go with both terms or 3 terms or however many terms is in the parentheses. Same thing with power of a fraction. The exponent distributes. Negative exponents. And this is tricky for a lot of people. A to the negative x. Any number is understood to be over 1. And what a negative exponent does is it flips the fraction upside down. That's how we get 1 over a. Now, if a happens to be in the bottom and it's negative, the fraction flips back up. And anything divided by 1 is itself. So the fractional exponent or the rational exponent is the last thing. The under the radical sign, the exponent under the radical sign is the numerator. And the index or the number outside the radical sign is the denominator when you go to a single rational exponent from a radical. And you're going to have to be able to switch back and forth. And this concludes some of the pre-skills that you're going to need to remember. So you might have to pull this up side to side as we go through some of these lessons as we go through this unit.